All right, welcome back to our YouTube channel. Today we are going to be discussing this new concept, which is hexadecimal. Now, in the previous classes, we went through some concepts related to binary, then related to denary, and today we are going to be studying the third number type of number system, which is known as hexadecimal. Now, hexadecimal is something which you should have studied in O level, but let's say you haven't. So we are going to be starting off with its basics. Hexadecimal basically refers to 16 base 16. Wait, base 16. What do we mean by the term base 16? Now, as told in the previous classes, base 16 means that hexadecimal could have 16 possible values. 16 possible values. By 16 possible values, I basically want to say that we could write like there are total 16 digits which could represent a hexadecimal. And what are those digits? Those are basically 0 to 9, which count as 10 digits because you see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 10. And then we have six more digits which are A to E, which are again six digits. A to E basically refers to A, B, C, D, E. 3, 4, 5, and 10 this. A, B, C, oh my bad. A to F. F. Yeah, I missed that. Let's erase this. Yes. A to F. So in total, we have 16 digits which could represent a hexadecimal number. Now, what's the main difference between the two? Basically, hexadecimal is usually used to represent large sort of numbers. Like let's say we have a binary code, which is, if we say 16, 15, what would be the binary code for 15? It is going to be 1111. Let's say if we consider it as 4 bits. And how did we get this? 1, 2, 4, 8, and so on, 16, 32. But when we add 8, 4 to 1, then we get 15 as our answer. But you see, this occupies a lot of space, like 4 digits. How could we shorten this? For that, we use these hexadecimals. So basically, 15 could be directly represented by the term F in hexadecimal. And we are going to be learning all this right now, which term is represented by what thing and all those stuff. So basically, the first 9 digits, let's make some space up here. Yeah. So the first nine digits, which are basically your 0 to 9, those are the same, like they represent the same thing. Let's say if I say that represent the denary number 3 in hexadecimal, you're going to be writing 3 in the answer, which would be hexadecimal. But this only goes up till the number 9, which we just erased. But this could only be possible if your value is less than 9. Let's say you exceed 9, which means if your number is 10 or greater. How do we represent it then? So for that, you need to memorize some rules. Those rules are pretty simple. Basically, the letters which we mentioned previously, A, B, C, D, E, and F, all capital, they have some specific values, starting with A, which has the value 10, B, which has the value 11, C, which has the value 12, D, which has the value 13, E, which has the value 14, and finally F, which has the value 15. So if I say that you need to mention the hexadecimal for the denary value 12, or let's say binary value 12, by binary value 12, I mean a number in binary, which again gives us the final answer as 12. What are we going to write? We are going to check, or perhaps we would have memorized this thing that A is 10. In exam, don't memorize stuff like C is 12, just memorize that A is 10 and F is 15, and then go like A is 10, B is 11, 12, C is 12. Yeah, so C. So I'm just going to be writing the answer as C, which is 100% correct. That's basically how you, this is like a very basic concept about hexadecimal numbers. Now, after this, we are going to be basically checking out how do you convert binary to hexadecimal. So let's mention the heading up here, binary to hexadecimal. How do you convert these numbers? Hexadecimals. Now let's say I have this number 01101101. In the question exam, they say that convert this into hexadecimal. Now, the thing is that doing this is pretty simple. Basically, you need to divide the entire code into sections of four. Like you're going to divide this 8-bit code into two 4-bit codes. You see, 1, 2, 3, 4, 4 up here, and 1, 2, 3, 4, 4 up here, 4, 4, 8. And why are we dividing this? Because you see, the maximum a 4-bit could represent is 1111, which caters to how what in ternary? A 15. So the maximum number which we could use a hexadecimal to represent is 15. We start from 0 till 9 and then A till F, where F is 15, the largest possible value. And because of this reason, we convert a binary code into groups of 4. Now let's say we divide this into two sections. Now, what are we going to do? We are going to be basically changing each part to the hexadecimal code as we did previously. Now, what's this part? It's 1, 2, 4, and 8. This comes up to be 8 plus 4 is 12, 12 plus 1 is 13. What is a 13 in hexadecimal? Check your table up here. It's a D. You see this D. Now, as it's a D, we're going to be mentioning D up here. Likewise, we're going to be checking this up here too. 1, 2, 4, 8. It is 4 plus 2 is 6. Now, 6 is less than 10, right? So if any number is less than 10, this means we won't be using any letters, perhaps because we have these numbers ourselves for it. So we are just going to be writing 6 up here. So we get the final answer as 6D. And now 6D basically represents this binary code, this one. 0, 1, oh my bad. This is the 1 up here. The 0, 1, 1, 0, double 1, 0, 1. This is basically represented by 6D. And if we were asked to now convert this 6D into denary, what it was basically in denary, we could just convert this binary into denary, which would have been 1, 2, 4, 8, 16, 32, 64, and finally 128. Counting up the ones, it would be 64 plus 32 and then plus 8 plus 4 plus 1. 64 plus 32 gives us 96, yes. And 8 plus 4 gives us 12 plus 1. And if we add it, this becomes as 98 and 108 and 109. This means 6D basically represents 109 number in your denary form. Now, this is the basic concept of hexadecimal. I hope you guys got what I wanted to say. Now, this was basically how you convert binary into hexadecimal, right? And likewise, we also studied how do you convert hexadecimal into denary by using the binary code again. Now, there are basically two methods of converting your hexadecimal code into denary. The first method is basically the one which we did now. You are given a hexadecimal code, let's say 6D, and you convert this into binary and then later on convert it into denary. And then there is a second form which includes you directly converting hexadecimal into denary, but again that is quite confusing and difficult. But before all this, we are going to be studying how do we convert a hexadecimal value back into binary. We studied the other thing, binary to hexadecimal, but now we are going to be studying how we convert a hexadecimal into binary. So doing that is also pretty simple. You have two digits, right? Write them separately, 6 and D. Now, in binary, how would you write the code 6? Like you're just going to mention 1, 2, 4, 8 and put 1 at places which total up to a 6, right? 1, 1 and 0. This adds up to 6. Likewise, D is 13. We're going to write a small 13 alongside this. And again, 1, 2, 4, 8. We are going to be getting 1, 1, 0, 1. Combine the two codes and we get 0, 1, 1, 0, double 1, 0, 1, which is your binary code. You got this, right? This is a pretty simple concept and there shouldn't be anything confusing in all this. Now, how do we convert from a hexadecimal to denary? The first method is that let's say you are given this code 6D, you convert this into binary. This was what basically I used to do for my exams. And then you convert this binary into denary by this method, 1, 2, 4, 8, 16, 32, 64. And when you add this, you're going to get 109, which is your denary. Or perhaps the second method, which is somewhat more confusing, and I wish I don't get the method wrong because I personally never use that method, is you have the base of hexadecimal as 16, right? And so what happens is that you multiply each number with its base. Like let's say we have d with us, 6d. So we are going to be multiplying 16 raised to power 0 first, multiply by the value of d, which is 13. And then we are going to be adding 16 raised to power 1 multiply by 6. Like this is the concept. Basically, you increase the power alongside. Let's see if this gives us the exact answer. I'm not sure though, because I never use this method, but let's see. 16 um, multiply by 6, we get 96, and 96 plus 16 raised to power 0 is basically 1 multiplied by 13, which gives us 13, and we get 96 from here. So 96 plus 13 is 109, and yeah, here is our answer. But the problem here is that, let's say if they give you a number like 7060, you won't be considering 76 as a single number. No, never. 7 is a different entity, 6 is a different entity, and D is a different entity. Now, if I had to convert this 7, 6D into denary, then I would have added 16 raised to power 2 multiplied by 7. And so that way 16 raised to power 2 would be 256 multiplied by 7, which could further make the calculations even more difficult. If let's say we had A up here, A76D, and they told us to convert it into denary, that would have been really confusing, because then we would have been required to do it like 16 raised to power 3 multiplied by A, which has the value of 10. And when adding up all this, there is a high probability that you make a mistake. But on the other hand, if we even convert this difficult code into, what do we call it, binary, and then convert it into denary, it would have been really simple. Like A. A is basically 1248. We have a 1010. 7. It would be 0111, because 1 2 4 6 7. Then we have a 6. We have 0. Uh, yeah, sure. Ask of Asad. You guys could unmute if you want to. No, they would never give you a 6-bit binary. Basically, as mentioned earlier in the class, you have either an 8-bit binary code, or let's say 12-bit binary code, or a 4-bit binary code. For the recording students or the YouTube students, basically we had a question that what if they give us only a 6-bit binary code? Well, they would never ever give you a 6-bit binary code, because that is an error. A computer could only store either 4 bits or 12 bits or 16 bits, 32, or something which could be a factor of 4. You get that, right? So it would be never a 6. It would always be a multiple of 4. So whatever the value or the binary they give you, it would always be 4. That is pretty sure. There is nothing confusing in that. And so, yeah, they would always give you a 8-bit or a 12-bit. Like let's say you see this code. This would be 4, 8, 16. This will give us a 16-bit binary. How? We are converting it right now. And so let's say we have 6 next, right? So it would be 1, 2, 4, 8 again, and we're going to be having 0, 1, 1, 0. And then finally D, which was 13, we are again going to be having it as 1, 1, 0, 1. So you see, we get this final answer: 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1. And this is 16 bits. Now they could test you on this. And you see, how do I know it's 16 bits? You have a group of 4 up here, then a group of 4 up here, then a group of 4 up here, and then a group of 4 up here. 4, 4, 4, 4, you get 16 in the end. So yeah, that's the main concept, right? You get it. And this, wait a minute, just give me a minute, guys. There is someone on WhatsApp. Let me just reply to him. Okay, problem. All right, so coming back to the class. Yeah, so this is basically how we convert the hexadecimal into binary and denary. The two methods which were discussed earlier include one in which you multiply it with the power of 16, 16 raised to power 0 for the first one, the most right one. 16 raised to power 0 multiply by value of most right, and then you increment it as 16 raised to power 1 multiplied by the value which was left to the most right one, and so on, 16 raised to power 2, 16 raised to power 3. But mostly if they give you such question, it could maximum go up to 16 raised to power 2. And for you should know this, that 16 raised to power 2 is basically 256. And once you know 256, it's quite easy, because mostly they give you stuff like 256 multiplied by 10. So you would know that 256 multiplied by 10 is 2560. Or let's say even if it's a 5, so that's easy multiplication, which most of the students would be able to do. Now, this is one of the basic concepts which you guys would have studied earlier in O levels. But yeah, we have discussed going from binary to hexadecimal. And then we have also discussed going from hexadecimal to denary, likewise from denary to hexadecimal. Yeah, we didn't do this. Let's say they give us a number 130 and they tell us to convert it into hexadecimal. Now for this, there are basically two methods again, but I won't be discussing that one method, which is really, really difficult because that is confusing. If I'm going to be telling you the tip or perhaps the method I used, and I would also suggest that you guys also use the same method because that is really, really easy. And what was that method basically? You convert this denary number first into binary number. Once you have a binary number, you convert the binary into hexadecimal. This is the most easiest method because the other method basically involves dividing 130 by 16, which is the base of hexadecimal consecutively. And again, you have the remainder stuff, which is really confusing and you could make a big mistake. 130 divided by 16, doing it without a calculator is really, really difficult. And so to prevent those sort of mistakes, I'm going to be teaching you all this easy method. And that's why I'm basically taking these classes. So you guys don't make these sort of mistakes. Basically, previously I wanted to take classes, but like for the purpose of my own interest, but now I also want to take these classes so that you guys don't make the mistakes which I made previously when I was doing my A levels. And so in the group, for all those who are watching on YouTube, if you guys also want to be added onto the our WhatsApp group, you guys could comment down there. And so it's like you could say a mission of mine to make CS a bit more easier for everyone. And so we are going to be discussing the easy method. Let's say we have the number 130. Convert it into binary. How do we convert it? 1, 2, 4, 8, 16, 32, 64, 128. As it's 130, we are going to be having a 1 up here and then a 0, 0, 0, 0, 1, 2, 4, 6, 30, yes, and then 0 and finally 1 up here. So this is our binary 0010 and 1000. Now we are going to be splitting this binary code into two halves. 1000 and now we are going to be using each of these two parts for a separate we are going to be converting each of this nibble. I told you all in the previous class, in the first class perhaps, a 4-bit is always called a nibble. So after this, I would always be referring to a 4-bit as nibble. So we are going to be converting this nibble into hexadecimal. And then later on, join the two hexadecimal values. What would be the hexadecimal for 0010? As it is less than 10, you see less than 10, we are going to be only writing the number, which would be 2 on its own. And for this, we would be erasing this. It would become as 1, 2, 4, 8. It would be 8. So you get your final answer as 82. This means 130 in hexadecimal is basically 82. And if someone asks you, what does this 82 mean? This doesn't mean that you have the answer as 82. I'm pronouncing it as 82. Basically, it's 8 and 2. 8 and 2. These two entities aren't added like their value 82. It's like you glue 8 and 2 and join, just write them together without any space. But it's not 82 in reality. Like, let's say if we could have said that it is 8a, and when would it have been 8a? If we had the value of 10 up here, which would be only possible if we had a 1 in here. And so in that case, it would be 8a. So yeah, that's basically the main concept, how you convert from a binary to hexadecimal and then a hexadecimal to denary, and likewise from denary to hexadecimal and so on. Now we are going to be discussing one very important concept which used to be which was there on the exams quite often in the O-level series, but it's also in your AS course, so I would prefer that you guys know about it. And that is basically uses of hexadecimal. A very easy concept. Basically, you get a 2-mark question in your exams saying mention two benefits or not benefits, perhaps uses of hexadecimal. And here you need to write all those places. You could like write anything which uses hexadecimal. And now we are going to be discussing the places where you could use hexadecimal. The first place is memory dumps. Memory dumps. You guys could make the notes later on, or if you guys want, you could write all this with yourself right now too. Let's write this up here, b equals to 11. Yeah. So memory dump is basically a location in your computer on your device where the computer's operating system basically stores all the errors. All the errors. So let's say you opened up your computer, you started it, and there was a issue with the graphic driver, let's say, and there is this error which says error hashtag AE876B54. Now, this AE876B54 may seem like a text to us. To a layperson, it may seem like a text, but to be honest, this is basically a hexadecimal value. And the purpose of using this hexadecimal value in this place rather than binary or denary is that if I had to convert this hexadecimal into binary, do you guys know how long it would have been? 4 bits for this, 4 for this, 4 for this, 4 for this. Just for this one part, it would have been 16 bits. And then 1, 2, 3, 4, 16, 16. This means 32 bits binary would have been used to represent this single statement. And just imagine if I were to convert it into like, because a computer only gets binary, right? It doesn't get the denary thingy. That is for our own understanding. And so if I had to write it in binary form, it would have taken the entire one line space perhaps, but here it is only taking 10% of the entire space, right? You get it? So there is also sometimes a question which asks, why are we using hexadecimal, or what's the purpose of hexadecimal? In that you need to mention, wait, let me write it somewhere. Hmm, let's make some space up here. Yeah. Purpose or use of hexadecimal, HD, referring to hexadecimal. And basically, the purpose of it is that it occupies less space on both memory and your screen. Sometimes it's 1-mark question, sometimes it's a 2-marker question. And so if it's a 2-mark question, you should go with the screen point 2. Perhaps even for a 1-mark question, I would suggest you go with both these points. And why is it necessary? Basically, uh, when you try to store the letter A or you try to store the letter 0, in most cases, it's just a specific part of a register, and so it occupies the same space. And because of that reason, A could store 10 digits, whereas a 0 represents only a single bit. That is why it also occupies less space on the memory thingy too, and also on your screen, as shown in the last example. And so this was one of the examples of using hexadecimal. And the purpose is only this one line. It only comes as 1-mark or 2-mark question sometimes. But the second point is something I usually forget, but it would be mentioned in the marking scheme once you guys practice your past papers. And so you could get to know it from there. In the book, there isn't any specific reference to the purpose of using hexadecimal, but there are the uses. The uses part is in the books. And so the second reason, or not the second reason, the second usage of hexadecimal is in your, where do we use it? Yes, you guys use it in um, web development, web development, perhaps color codes. The question basically sometimes refer you This is for the broader concept. You guys have to write color codes, not the web development part. That is just for your own explanation or understanding. You guys basically use it in color codes. What do I mean by color codes? Have you guys ever used Paint or any of the editing software? You always have stuff like hashtag and then A, B. Oh, wait, let me make it up here. Let's say a pen, and we go to more colors. Don't we have that in here? I guess we don't. Can't I just change it up? It should be there, but I don't know why it's not. Okay, so basically you have specific colors. I saw it somewhere, but I don't know. It's not there right now. And let's just change the color a bit too. Yeah, a darker color. Let's use this. You have this code like let's say AB7600. And this code basically represents a specific color. Wait guys, let me print it out for you from the Paint app. Let me just take a screenshot and paste it up here so that you guys could understand what I want to say. It's not up here either. Just a minute, everyone, for your understanding. Okay, we don't have Paint. All right, let me just take a screenshot of this thing. Color codes. Color codes. Color codes. Yes. And here we have different colors. And let me just snip it up. New. And we have this as an example. Copy. And let's go back to class. Yeah. So you see, we have this specific example code. Let's take this. Let me just select this image and enlarge it. So yeah, you see, now here we have it in several forms. RGB. RGB basically refers to red, green, and blue. And so this code is basically indicating how much of red color is being used, how much of green color is being used, and how much of blue color is being used. For your kind information, this isn't related to CS, but is more of a physics concept. All the colors come from the basic three: red, green, and blue color, RGB. And that is why we have this RGB. And this is one other which is CMYK. Basically, this you are going to be studying this in the printers subject topic. And so let's skip it for now. Our concerning thing is this hex part, hex. You see this code, hashtag 5527FF. This basically is a hexadecimal code. HD code. And the same thing was something I tried to make on my own up here to AB7600. And so this AB7600 basically is a hexadecimal code too. And now the question basically asks like, it's like of a 2-mark question, and it says list 2 scenarios where you could use hexadecimal code. And so the first one you could go with that memory dumps one, and the second one could be color codes. And now let's discuss the third one. The third one is something very easy and which many people don't find confusing, and that is IP address. Now, IP address is of two forms. You have the IPv4 and then we have the IPv6. The computers which we currently use that has IPv4 because our technology isn't that advanced right now, but IPv6 is the new latest technology. And you would know that your IPv4 code is most probably going to be something like 192.16.10.8.7, something like this, perhaps just till here 192.16 something dot 10.8 or whatever the number is. This specific code is IPv4, but the latest IPv6 has it in a form of like 88 AE colon 77 6B colon FF 82 colon 42 8A. And so this new form This basically uses hexadecimal. Again, you see the old one, 192.16.10.8. This has only numbers in it. And so this basically uses denary. And as denary is base 10 number system, we have limited devices which we could use using this IPv4. And for that reason, we had to come up with IPv6, which uses base 16, due to which we have a larger capacity. We are going to be studying this later on in chapter number 2, and I don't want to go into detail, but this is something you guys should know, that IPv6. So if you want to mention IP address in the uses of hexadecimal, just state that IP address and then also mention IPv6 only. Okay, so we had a message from the Zoom and we have the last 10 minutes of the class. Okay. And then apart from that, we have the fourth example as the MAC address. We are again, as mentioned earlier, would be discussing the difference between MAC address, IP address, and all those stuff in the later on coming chapter. But this is something which you guys should memorize by now, because these concepts are basically taught in O levels, not in the first chapter, in the upcoming chapters. And I'm also going to be teaching you all those later on. And so no need to worry, just chill. And so MAC address also uses these hexadecimal values. Your MAC address is something like AE74, and I believe not a comma, it's a full stop. Yes, full stop EF4D. I'm not sure if it's a full stop or what, but it's something like this. And so you again see you have digits and alphabets, but the alphabets are only from A till F. Now, wherever you see digits and alphabets from A to F, just get to know that yes, this is a hexadecimal code. Now, this question hasn't been tested up to this very moment, but let's say they give you a specific hexadecimal code and say that what's the problem with this? Let me give you an example. Wait. We have this Z9O4. We have this code. The examiner says that this is a hexadecimal code stated by student 1. Student 2 says that there is some error and this isn't the correct hexadecimal code. Why is student 2 saying such statement? Now, this statement is usually something which they could test you only in your O levels or IGCSE, because in your A levels, they usually test you on more further advanced concept, but still for your knowledge, you guys should be aware of this. And yes, 100%. Asad got the correct answer. And the reason behind this is that there is no Z in hexadecimal. You only have code alphabets from A till F. If there is anything after F, let's say GH till up to Z, this means it's not a hexadecimal code. And because of that reason, you have this as an invalid statement. Now, this could come as a 1 mark question, and you guys should be able to answer this. So this is basically the entire hexadecimal concept, and I believe you guys understood what's hexadecimal all about. In hexadecimal, you guys should know the conversions. This is basically something which they 100% test. Like there's a high chance they test you on conversions. And then there is the uses part and the purpose part. Okay, and then after that we also have BCD, I guess, but that's a bit of a new concept. I would be discussing this afterwards. I won't be mixing it with the hexadecimal thingy. But hexadecimal conversion, uses and purpose, this is something which we have learned by now. And in your A-level exam, you are going to be first getting tested for 1 to 5 marks on the conversion. This would include all the forms, all the three number systems: binary, hexadecimal, and your denary number system. And then this question, uses and purpose, this is really tested in A levels, because this is more of a O level or IGCSE concept, but still they could test you on it. We don't have any information because it's there in the course. And also, for all your knowledge, I will be teaching you all a method of how to use your calculator to convert between binary, hexadecimal, and denary. but obviously you don't have your calculators with you in exams, and neither you could take it with yourself. And so it's better you guys only use this method of calculator. I'm going to be making a short video on this later on. I'm going to be posting it on my YouTube channel and would share it in the group so that you guys could know about it. But you guys should only be using this for the purpose of what do we call it, just to check the answers. Let's say you do a topical question, which I'm going to be giving to you all. I'm going to be making a worksheet, which inshallah you guys would be doing in the later part of July, which would be testing all of these concepts. And there you get this answer as 70. Now you want to test whether 70 is correct or not. You're going to just put the values into your Casio or whatever calculator you got, and you will get the correct answer. If it's correct, well and good. If not, just use the group and ask others for help. And so we have the class ending right now, the meeting perhaps. I'm going to be closing this meeting, and I'm just going to be launching one another where we would be discussing BCD. For the YouTube users, I might publish the video later on for the BCD part, but yes, it would be there on the YouTube channel. So yes, that's all for today. And so don't forget to subscribe our channel. Alright, that was for the YouTube thingy people. And so I'm just ending the screen right now, closing the recording, and you guys should join the new recording.